So part 3 is going to be a little rambly because it's not a real presentation. I haven't given it publicly yet, but it's basically trying to summarize all the things that have come before. So what do you do with the fact that you get the data out? What are the big challenges? What are the capabilities? What are the things that become real opportunities when you start to do this? For those that complained in the first one of these, I've made sure to have one cat, and there's always a good internet reference, so my endgame. So again, my goal here is to provide a sort of a blueprint to sort of enable the industry to remake itself. I'm not trying to do that myself. I'm not trying to start a company. This is just a website to sort of tell the stories. I'm certainly working on a lot of efforts that sort of come into play, talking to firms, working on open standards, but I think it's most important to me to give the playbook, sort of the end game discussion, do that in public so everybody understands and can, convinced is not the right word, but try to understand and react to the ideas. So if you've watched any of the other presentations, you've seen this graphic, just this idea that currently our sort of tool set sort of logically thinks it's owning the data, and it's logical because that's the way we've let them operate, and I thought that that's the best way to operate in the past. Let is a stretch, but it's basically that's how we were very comfortable working. In the new model I'm proposing, basically what you do is doing the work to get the data out of those applications such that you can have an application-independent representation. So the way I've always thought about that is, given the way tools work in AEC, we don't have data standards that can be bidirectional. So as a starting point, what you do is sort of you get the data out in a read-only fashion, so metadata and geometry. So what I've shown previously is doing the work to get the data out. But what's interesting, there's actually some really important things here. Obviously, the version control things that I've talked about previously. But at this point, you can actually do some really interesting stuff, like QA, QC analysis, drawing automation, which I'll touch on. You can make helper tools, especially if this is a real-time sort of capability that you're able to get the data out, sort of suggester systems, all the kinds of things that come with reuse because you could build tooling around standard data. So if you do these two things, there's some pretty significant benefits that come from this, but clearly you need to be working on an editable data and geometry sort of format. I've said before, I'm pragmatic. IFC is the thing I've done my prototyping on. It's well set to actually handle this. It's just never been architected to work this way. I'll talk about what I'm doing to help that discussion. But if you were to compare from the VFX space, basically this is the place that they've sort of architected USD to work. So it's ahead in this discussion. But largely, I think the most important aspect is this is where new tools come in. So it could be the same tools, but just the change of the way they work. So instead of thinking about them having their own proprietary data only, they actually author and work with the sort of open data representations. But then at the same time, it becomes much simpler for new companies to come in. And there's something to be said about market inefficiency, especially in the venture space, where we're seeing so many new entrants that most of their time, I would venture 60 to 70% of the effort to being a startup in this industry, especially if you're going to touch geometry, is around inventing a geometry representation and interop, which I think that might even be forgiving to say that it's 70%, which basically means around functionality, you're spending 20%, 30%, I think, maximum on building tools that actually have user experiences that you're looking for. So to me, it's important to recognize that there's all kinds of reasons to do this, and this is where new tools should come into play. I'm very much not an advocate that we should have new monolithic tools. I don't think there's a place for those. We have plenty of them. They should be able to work in this environment as well. But you should have a bootstrap company of 5 people, 3 people, and be able to solve a real problem in AEC, and I think this is the way to do that. So if you're to look at the data stack a little bit more, I think it's important to really understand that in my little triangles here, we also have a problem of ownership and a concept around sort of distributed ownership. So I gave pieces of these presentations in discussions about modernizing IFC, which is one of my efforts I work on as a co-chair of the technical room within Building Smart International, and we're actually making very good conceptual progress in how to do exactly this. But the key is, like, if this is a floor slab, and doesn't matter, it comes out of Rhino, it comes out of Revit, it comes out of ArchiCAD, Brixis, Vectorworks, you name it. The point is, no one entity owns that slab. So first off, you might, depending on the project type and location, you might have different sets of attributes that want to be attached. Like, material information might be best handled by a combination of a structural engineer and the architect, so you might actually have two, or you might separate the life cycle cost information out. That's used for calculations or life safety things. So what you start to see is actually there's a whole host of these, the terminology I'll use is components of information that make these up versus what we have today, which is really a approach that this is one object, and there might be copies or different versions of it, but there's only all the information associated with it is sort of held within a single software. But if you extend that out, we obviously have multiple geometric representations. This is the world that sort of I live in, that you might have the driving geometry, the structural geometry, and the idea that we can't actually assemble this today is an important problem. So as we look to getting the data, we have to actually think about getting the data in a way that you can sort of assemble that floor slab versus having to deal with multiple copies of information. So you extend this out, things like classifications, design review issues. The point of representing this way is actually showing that how you can, if you start to think about data in a graph or another kind of representation that's segmented, you can actually attach things directly to the data without having to go through a person, anything. So imagine being able to do like clash detection, and the clashes immediately get attached to the slab because they're just another kind of component. They don't have to have full write access to everything. They don't have to be owned by anything, but one application could own clashing and just update the floor slab and say, here's my clashes as of today. Now all these things would need to be versioned and these sort of important aspects, but I think fundamentally this representation is a needed one. And you add drawings and other things onto here. This is part of a presentation I gave to talk about this particular topic around modernizing IFC, which is to say, how do you, if you describe the same problems that exist in IFC, what do you sort of have to address? And the first couple things are things I've talked about previously, which is sort of version control, because really what you need to do is sort of, even if you're looking at it in a monolithic way, you need to look at it as a version data set that doesn't have to be replaced every time you work on it. But then you have this multiple owner problem. So the idea that, let's say we have light fixtures. It's not perfect, but it's a good example. On a large project, you'll have sort of an architect or interior designer, depending on where you are in the world. They might own the location and the shape, let's call it that. If you have a sort of a big enough project, you'll have a lighting designer that's really owns the bulbs and the performance. If you're the electrical engineer, your view of the world in this set of fixtures is around the systems and connectivity, low voltage, whatever. And today happens all simultaneously but disconnected. And to sort of rectify these views of the world, you end up having to duplicate information a ton. And then at the same time, you'd want to enable the contractor to start procurement. And they should be able to own the components around procurement, such that they don't have to share it with the architect, electrical engineer, lighting designer. But at the same time, if there's things that are shared, they can have a shared representation. And then finally, in the asset management world, like let's say this is a renovation project, these things already exist. Now they're moving into new representations, so you have time and history, and our data standards have never really thought this way. They've always sort of assumed that, it's one set of consistent data, and I think this is a big problem. We actually have the same issue when it comes to something as simple as spatial representation. So, even though there might be a same owner, like an interior designer or architect, there's multiple representations we need. We need net area calculations, special calculations for clients, gross area calculations, and like volumetric representations for quantity takeoff or energy modeling. At the same time, that's the same space, right? These are just different components or ways of looking at that same space, and this should be assembled, not, you have to choose which one you use. So the terminology here is actually to think about this as an entity. So this is terminology that's taken me a while to figure out. I had inklings of this idea in 2014. I would call this like a meta object or something like that. But basically this concept is, if you have the entity doesn't hold all the descriptors. The entity is just like the thing that links everything together. So like a set of properties, if we're talking about that space, the net area is an object that might have sub-components, which are geometry and the properties, gross area the same, and like the volumetric energy. So you're disconnecting an object from these representations, and different tools can own different components of this. And that's sort of the point of thinking about the world in this way. So this actually, the terminology that I'm going to talk about is entity component systems. So this comes from this sort of gaming sort of view of the world, that if you want to make a game modular, that you can make it scale, allowed to use multiple processors, that you start to sort of reject a pure object-oriented approach, and I'll show you what that means. But this terminology, entity component system, is all of a sudden quite popular, I think, in the AEC space for a good reason, because it solves things, whether the terminology is shared by all. But when you're talking about IFC, let's say, or any data representation, it's not a software, but to me it solves the same things, and that's why I've sort of done the work within Building Smart to start to have this discussion, and this is where we're sort of headed in our upcoming work to think about modularizing IFC. It's not lost on me, and it shouldn't be lost on the world, that sort of this is showing up with all the major vendors as well. They're thinking exactly the same route. A lot of them are working on data structures independent of applications, so they can sort of link all different tooling together. And specifically, if you want to look at a sort of industry example that's published, is Forge Data Exchange explicitly calls out this architecture and gives a very good discussion on it, but you'll see it in other places as well. But the point here is, even if you're talking about data, we need modularity, we need to think about composition, we need to parallelize our process, even if it's not software parallelization, and we need to isolate. We need to have things that are secure and non-secure on the same object, and this is not possible today. So I mentioned this object-oriented sort of issue where, if you look in abstract, these two doors might look exactly the same. But in reality, depending on your viewpoint of the world, once this becomes like the exit door, if you're the architect, you might need to associate a clearance volume to make sure you're meeting code requirements. They might have the same hardware, but there might be additional hardware you need to add to that door. And they're, like the same frame, the same panel, maybe. You might do something special around fire construction, but largely they're the same object in a classic object-oriented approach. They look the same, but what you're doing is assembling different views. But what we don't do at all today is like the notion that that actual door includes that sort of activation panel, like if it's a panic button or bar that has an electrical low voltage connection, or if it's got a camera associated with it. We don't have a way to think about building this relationship such that you can think about that. These are all just abstract objects floating in space, But in reality, that's the object when it comes to a holistic view. If you're the electrical engineer, you might have a subset of interests of those things. If you're the architect, you might have another subset. If you're a structural engineer, you might just care about a lintel. And then if you're the contractor, you might care about all, but your subs need to care about the same limited scope as the engineer. So this is a sort of classic example where this entity component approach is sort of shows up. So like if you look at those sort of two doors, they share everything on the left here, so I just didn't fill those out. So opening frame, panel, hardware, but the B door, the one on the right, has clearance, special hardware, controls, cameras. That should be the way we look at assembling this object. And it doesn't have to be assembled by one entity. Some of these could be assembled separately. And it could even be that one of the components here is actually sort of product data in the future, or it could even be application-specific things to make this easy to model. So if that's the sort of big picture when it comes to once you get the data out, what are the opportunities, where do the benefits come? One of the things that I sort of thought from beginning is that one of the reasons we're doing all this work to put data into singular applications, and for good reason, because the tooling exists and they're pretty good at it, is drawings. And I looked at that as actually the real limiter to do this. I'm firmly in the camp that we should make drawings closer to free, which means faster to produce and automate it as much as possible. They actually have to obviously serve the goal of why drawings need to exist. But at the same time, they're not going away, and there's always going to be a use for a kind of drawing, whether you call that a view or you call that something, sort of displaying and augmenting a model in a 2D representation is going to be something we need. So when I look around, I look for samples of tools that are doing just that on IFC. So this is a Korean tool that's built out of a sort of collaboration around code checking. So what you're seeing on the screen is an IFC model, and on the right in this side is a drawing representation that comes directly from the IFC. Not perfect, doesn't do all the cleanup things, but it does some nice things like these levels are in the IFC, but they're not graphic elements in the IFC. All the floor plans, if you will, are in the IFC, but they're not drawings per se, but it's sort of quite easy to make rules around those. I've done work with Brixis to think about how you would automate this in the future such that you have view plan types. So for this floor, make 15 kinds of drawings and help me automate their setup. Things like object replacement. Instead of putting the 2D representation, the perfect example of this, instead of putting the 2D representation of like a fire extinguisher, everybody realizes that like in a life safety plan, a fire extinguisher is a symbol, or especially like in an egress plan that you see by an elevator, it's like super abstract. Don't put that in the content, make that a mapping that can be held externally. So learning from that to see that this is definitely possible to take sort of a multi-representation approach. So here's a 10-story building. You would call these the A100s in the UK market, sort of the 1/8 or 1/16 level plans, especially should be automatable completely at this point, such that you can just say for each of these levels, I need this kind of reflected ceiling, I need this kind of floor plan, and generate 50 different kinds of views: life safety, power, electric, layout, and so forth. Certainly not everything is perfect and automatable in the work that I've done with Brixis, but we have other examples where people are looking at different efforts. And to me, this is a really fruitful space to spend our time because it frees up where we can produce work. So if you can get data into a standard format, you can work in any number of tools. So this is another example from Greybert. They're making a set of tools that do drawing automation out of Revit and IFC. So this happens to be IFC, but basically, again, a BIM sort of drawing approach where the drawings are abstracted from the model, but you're not, how do you say this? you're not making dumb drawings. You're making data-rich entities that are linked back to the drawing representation, which is how all the major BIM tools work today. And as we do this, we obviously should think about, like, I use the word drawings. Some people like the word views, graphics, 2D overlays. I think like everything you see on the screen is an example of something that should be part of this discussion. Assemble data, make views of it, and make it representational. So I like to think about it as for free, and free I mean automated such that you can work in a model. If you make rich data in a model, you can get good drawings. But it's also instructive to think about how we handle rendering today. Some tools are rendered in the application, but the most sort of robust and dedicated tools to visualization or rendering, live or not, are actually separate. And I think this is a very good sort of corollary to this problem. That drawing automation is a pretty big deal, and if somebody focused just on that and less on having to focus on all the modeling tools or all the specialty modeling tools, you could actually make some really, really interesting innovations there. And it basically means that all the content that comes out of our existing and new applications will just feed into that process. So you could, replace, in this kind of drawing, replace toilet fixtures with a manufactured fixture, or some other representation for a plumbing drawing, or a rule-based approach would definitely be the way I look at seeing this getting solved, and actually being part of the opening up the market project. So there's a bunch of other big picture stuff to me that's important when you start to look ahead. I'll say this is the place I've spent the least time lately, but at the same time I'm have spent time on it over the last couple of years. So it's sort of a grab bag of stuff that I sort of see that we don't address well in the industry that is linked to this big picture topic, which is opening up the data. So first off, I say that, and this is the least connected with that, but it's just pointing to the notion that right now tools are often built for the same end user all the time. And I work in a big firm, that's certainly part of this, but even small firms and small development processes share these things. So I'm a big fan of making the sort of the link between we look like software development. I've made the link to we sort of look like the film industry as well. But like the technologist within a firm today, like you could call them a BIM manager, really is not in a position to orchestrate really what they're in a position to do at the moment is teach and drive end users to work in a certain way versus actually applying knowledge to the technology itself. The corollary sometimes that's been pointed out to me is like in the software development world, if you're making builds of a project, as in, you take software, put it together, compile it, and distribute it, test it, that's a role. We don't have tooling that actually thinks that way, but to me, this is a perfect example. Like if you're going to sort of make a layering rule system, this would be something that a technology expert could orchestrate at the project level without having to open every file, but you'd start to build it that way. Then you'd go on to the content knowledge expert. This is basically where you can apply experience simultaneously across projects. So the idea that, let's say you start a project, and I'll use the American terms here because I'm blanking on the UK ones as an example, but let's say at SD you can sort of really map out all the wall assemblies, door types, and all these things that should be used in certain situations on the project. But the design itself is still in flux. We don't have a system where that knowledge expert, like a project architect or a experienced designer or engineer, can really say, okay, these are the kit parts we're going to use in these situations when somebody goes to sort of build that project, and this is where you go to the synthesizer, that they actually just use that knowledge directly in the tools, and this is where they're really the assembler of that knowledge. So we have three roles there that we don't design explicitly for. And then there's obviously this sort of very logical one, which is somebody that makes tools for this environment to fit into any one of these categories, and then like the sysadmin, like the unseen manager, which could care about security, deployment, tool access, account management, all of these things. And it's important, at least in my mind, that we start to realize that, like, if we're not doing it today, we should steal all the roles we can see parallels in the software world, because they're important to really digitize the process. So, software development in an odd way, without all these rules, is pretty undigitized. So, to me, it's an important way to think about it. I think it's important because, like, you have to think about these big things, because this diagram of something I've had for some time is our world is very getting more distributed all the time when it comes to application solving specific problems. But the problem with that approach is, well, they're valuable. If they don't talk to each other, it basically makes people become human APIs. And I think this is an architectural problem, because maybe in the architecture space, you touch so many different disciplines and into different spaces, but it shows up everywhere. Like I know firms that have 1,000 pieces of software. Not all of them need to interact, but fundamentally, this problem where people are at the center of it needs to be replaced, where sort of the data can talk to itself. So I won't read this. You can pause if you want to go through there. This is a sort of the way Greg does presentations, is he writes everything down and then he will replace it with a pre-slide. I don't know how to talk about this one all at once yet, and I thought it was too many slides, but basically there's some big ideas about how tools need to think about helping people. So like the people section is of it, talking about make sure I have the data I need to do my job, not make me go get the data. Dependencies is all about, if the knowledge expert can do the work in early phase of a project, like the experienced project architect or something, or experienced engineer can make the decisions to say when these things occur on this project, this content, rules, whatever have you, are used. This is the out of order workflow idea. Conversion is basically what I've been talking about, getting data out of the tools. Speed of an implementation is a obtuse idea about thinking or about what actual efficiency looks like an AEC. And then as we start to think about applying compute, like automation, to things, we need to start to think about sort of computing more than one path, such that you can, as people work and as projects work, we can actually do things like, I've already looked at if you were to make this choice. And you don't do this for everything, but like, let's say, if you use this column system versus that column system, how does it affect the architecture? Right now we sort of do this one at a time, but this future branching idea that you sort of think about, I'm in a current state, everything behind me has been decided, everything in the future is still open. Help me understand what happens if things go in different directions. So this is, again, sort of an obtuse list. There's spelling errors and all kinds of things, because this is how Greg works, but that's sort of the state of the world today. And I've talked about this in the API, human API discussion, because this is just a good example. I think there's 13 different places that drawing information shows up, at least in the cards here, and I think that includes the 3 dots. But basically, this is all manually coordinated today. Painful. Owned by different groups of people, different phases of the project, different use cases, but today, like, you change one material, you could have to sort of, depending on where, if you have to get it in front of a client and readjust quantities and cost and life cycle, and render it and whatever, you'd be spending weeks putting that information together. And that just speaks to this problem that each one of these apps that are starting to show up take a copy of the data, and then you have to do the work of rectifying it. Switching gears a little bit, but I think it's something we have to address if we really want to sort of plan ahead, is sort of modeling paradigms. And it's really speaking to the idea that computation and hand modeling need to be friends, and which is not really the case today. And I'm sure people can dispute this, but fundamentally we sort of have this sort of split between computational sort of order of operations, and then, well, if you want to manually influence something, you've broken it. And I think we have to come up with a way of rectifying that. And so, at least to wrap my head around it, I think I agree with this view of the world that today computation is easily applied here. I think that's a word. And here. And the point being, like, in the early phase of a project, you can assume you own the whole world. And I mean, by the way, by you, I mean one software, one or a few kinds of users. So it's really quite powerful to use computation here. When it comes to sort of the messy world of coordinating against hundreds of potential systems and different users and different sets of knowledge that can't exist here, it gets really hard, and we often sort of go to a hand modeling approach. And then when you get into construction or even late design, I think computation in this area becomes easier again. Like, okay, I know all the details of my facade now. I've integrated with all the decisions with my HVAC system and so forth. I can just implement it such that, replace all these panels. I think this is a big area of frustration in our world, and sort of has meant that we don't actually work together in this way. So the state-of-the-art view of the world, I'm using the word functions because it's been popularized lately, but basically just think of it as like one sort of battery, if you will, in Grasshopper or Node that does something, you pass it on to the next one, and so forth. Well, what this does is means there's no space to sort of break this chain, especially if you want to break it over the life cycle of a project. So the terminology is weak. I'm sure somebody that's looked at this problem could really look into it in more detail, but this rendered cache approach is the idea that, well, actually the output of this function should be sort of in the open data format, and while you work, it's passed directly onto the next function, because this would be a really speedy way to operate. But if you sort of decide something, what you're actually doing is by function 3, if this is fixed data, you should be able to come back and operate on this. So live while you're working, and version states of actually decisions of each one of these steps. So the idea here is you could introduce sort of a direct edit manual modeling, or you could have like the automated piece, or you could substitute totally different modeling paradigm, but you're not breaking this sort of computational logic. And to me, this is the sort of big thing we have to think about as we start to integrate sort of automation in our tooling, is that we can't just have one or the other. We need to mix both. And this basically is me just writing down and capturing the ideas that you want to mix the two. You're going to need to think about saving these things. It's not computationally efficient to think about it this way, but it's actually, I think, what's needed. And would allow sort of functions to be replaced with other intervention types, like, scripting, or any of these things are, sort of, I got this new object from a component from a contractor that has this information in it. Take it from here. It would allow an evolutionary process. And then sort of benefits of this, I haven't read this in a while, but I think I agree with all these things. Again, it's just speaking to this notion that we need to replicate, or not replicate, fix this relationship we had with the sort of the manually modeled stuff in the computational approaches, and sort of thinking about them in the same way makes a lot of sense. When I do something hand modeled, I generate a result. When a computational process generates something, I generate a result. Both of which should be outside in a chain that can be accessed. So the next group of topics is really the biggest place I point to wanting to steal from the software development world, is the user experience. And I've had that graphic up before where I show the sort of human APIs. I really made this list a while ago, but I think that the biggest one here is the user experience. And so I've talked about version control, distributed working, like in the sort of super wordy slide that the data comes to you. You don't have to go get it, so it's available when you need it. Directly addressable data, targeted, some of these things are a little bit more obtuse, but let's just jump to this IDE thing. To me, this is the most important one. So I look at the way software development works, and I see that most people, and there's variations on this, today use a sort of GitHub plus their preferred coding environment. And that coding environment is called I'm sure someone will fight me on the terminology, but the coding environment is often called the IDE, so Integrated Development Environment, and that probably means more to some and less to others, but basically it's the place you edit code. That's the way I'm looking at it. So it's a couple things. It's often project-based, so you connect it up and it knows which repository you're working on. So when you open a project or a folder, you don't have to relink to all the resources that belong to it. In a Git-based process, it delivers all the data down to you, right? You get the updates, and you don't have to, if somebody's committed the work, you have all the updates. You don't have to look around, go to a different website to pull things. So the idea that in the software development world, everything comes to you, and if you need it, you have it. And that's largely true. There's some edge cases that's not. Versus what we have today, which is I need to assemble everything, and I go to the data, bring it back to where I need it, and translate it. And I think this is the wrong approach. So imagine if you're working on a Python application and you had to go to a web page every time somebody made changes to one of the libraries that you're using on the same project, or a function. It just wouldn't work nearly as efficient. So the IDE for me is something we should copy for two reasons. One, it's the user experience. Start to think about projects being collections of different data contexts and tooling, and bring those to me in such a way that I can work on them. But the second thing I really see here, and something you see, is actually bringing discrete linked sets of data together. I mean, conceptually linked. So I look at the example of the material problem, and two examples I'm trying to show here. One is the specifications and the material list. Two places where material information show up that I need to coordinate. And right now we have two separate apps. So if you take the idea that bring the data in a centralized application, which software developers sort of largely experience, we should think about that process in such that actually the apps do the work of helping you make these links and build. If you can't just help actually make the coordination, help you build the links, so if they become out of date, they help you fix them. So this is a perfect example. Think about this being two apps: my spec editor and my material list. Maybe I'm the owner of this and I'm not the owner of that. But if I want to coordinate them, I should be able to sort of work between them, bring them both up in the same context, and as I make the connections, the data is actually making those connections such that if this changes, I know the spec is out of date. Or if the spec changes, I know I have to review the material information. But this is, to me, how you start to think about digitizing the process, because there's so many of things in our industry that look like this. So one app, the other. If you look at sort of on the project, library side of things, materials and specs, materials and products, code and products. There's tons of these things in a library, here's my one door in the properties and all the different file representations I might have as a starting point. That's one view of the world. And if you look at it this way, it's sort of just looking at gaps we have in a very simple workflow today. So let's say I have a door, and today we have to have details, 2D details. And that door might have a preferred product, and that preferred product might show up in our standard spec, and that might be used on a bunch of projects, and we might have a list of substitutions that the CM comes back with. None of this is linked today, and material as well. So the idea here is, like, even from a simple standpoint, what if I use this door in a project? I currently today have to manually recreate all these connections versus, well, if the data is connected and linked as I work, I can already tell the tool that I'm making my drawings in, you need to include the details for this door and this wall condition. And again, this is sort of just a very abstract view of it, but I think this mentality sort of can be thought about in many different places. Here I have a set of renderings. If you're unfamiliar with renderings, you can do these things where you show material ID by a separate color. Why wouldn't we look to take advantage of that and actually say, well, do I have coordination between my material list or specifications, and use that in a sort of consolidated way? Again, bring data in one representation linked to the other as we move forward. So again, two separate apps. There's hundreds of these things. It really just speaks to the fact that we don't have a way to think about these as part of a big mess of data that needs to be thought of as chatty, but not in the same applications, but the data itself needs to talk to each other. So, like, if you need to sort of coordinate materials, you might need these resources of data, and on this app you might need material and rendering as well. But the data is a resource to the application, not part of it. And this is a key thing that I'll talk about ad nauseum, and this is the fundamental idea I'm sort of pushing. And this goes to sort of a graphic I've shown before, is the same concept links to a model. So if I can get model information, I can talk to it with any other app to make links. I can sort of make the connections between things. If things change, I have the versions, and I can sort of only have to worry about the things that need to be updated. And the same logic can actually be pushed back to the authoring tools to, sort of have this same relationship. There's nothing to say that this tool, like these two tools, can't live in an authoring tool. Like this one could be living in the authoring tool, but it talks to the data the same way if it's outside the authoring tool. But fundamentally, I think this is the sort of user experience side of things that we really need to think about, because our world is just way too complex to have hundreds of user experiences per every product. And then there's just some, I'll just lastly say these are experiments that I've done. So this is, well, why is our model checking, visualization, review, storytelling, why can't those be the same world? So looking at a game engine, can I make and this is an experiment I actually did, and I'm not a programmer, but I'm good enough to hack something together in something like Unreal, is can you build a clash detector in the visualization tool? Answer happens to be yes. This is just turning on scope, so basically what is it looking at? It's not as robust as some of the sort of dedicated tools, but at the same time, this is me spending a weekend. So the sort of convergence of need is provable. Whether this is the right way to handle it, I just wanted to prove out the idea that, if you have the data assembled in its richest form with sort of rich model data, material data, performance data, what have you, you could assemble it in a tool and do more than one thing in one place. And then just from a user experience standpoint, are there areas that we're not innovating around just basic model representation? So why don't we have a slicer that's sliced by system, by sort of what this is basically showing is sort of section a model, but only section the system I want to section and not the key things I want to look at. So just, again, experiments around understanding, are there gaps in the tooling that we have today? And then some very, I would call this obtuse stuff, but if you haven't figured out, I'm a nerd when it comes to this sort of stuff and go pretty deep. But I think long term, we want to start to think about it, what's called a DSL, sort of a domain-specific language. And I'm not saying this is a requirement. I'm just saying that there are some fans of this concept in the industry. But the idea here is you actually have a way to provide the descriptive components of the world on top of the data representations. So I have this old mock-up that I made called Bill, which was like a scripted programming language we've actually done some prototypes of. But the idea is you could think about requirements as a scripted things, and the words in here actually take on meaning. And that, to me, this is the most important aspect of when you're thinking about this. Like, this little thing is supposed to say, let me go into a data set and set the floor to floor and equal to 15 feet. Okay, that's a very understandable thing, but from a computer to do that automatically, you have to start to think about, well, what does floor to floor mean? So is that top of finish to bottom of steel, let's say, in that building type? This level of specificity we don't have at all, but if you want to really start to improve computation or links to machine learning or future stuff, we need to start to at least codify meaning. We don't have to have the scripting, but we need to know what floor to floor means in a computational approach. So again, this is sort of very old work. I think this is from 2011, but I hope in all these talks you get some convergence in the way I'm thinking about these things, like how do you bring all these concepts together. Like I said, and then I'll just lastly on this convergence topic, I showed this graphic previously, but I didn't want to skip out the fact that this is the way a lot of the software companies are thinking. And so I think it's important to take advantage of this moment to really understand that, if we want to move the industry into a more open representation, we have open standards that are sort of used. Things like GLTF, IFC, USD fits into this category of these things you can start to assemble. GLTF is thinking about how you can make an assembled scene of multiple GLTFs. I think it's like a very important, interesting moment to start to say, well, actually, this is the way we need to solve the problem. Our commercial design tools, if they're going to go this way, we should think about making sure we have the tooling to move across tools in this way, and that's definitely, again, where I'm spending my time on the building smart side. Not because IFC and its implementations are perfect, it's that it's actually a framework to sort of advance these ideas that I can help advance. So finally, going all the way to the back, where did I sort of think about starting? Well, I like the model of sort of thinking about sort of this kind of radar chart view of the world and think if we spent the time, what could we do? So to me, drawing automation is a good example of places that like it takes away from having to work on other things, and that's a huge part of why you do it. Like, we have to do it, let's make it really quick and fast. And then what if you map to no one's doing it at scale today? There people are certainly doing it, but it's not to the point where it's sort of you could combine data from 3 applications and replace what you might get out of your traditional BIM tools. Design twin, this is a concept that I might not use, but like digital twins became all this thing, so I was like, I'll just put a marker in the ground to say, like, there's a version that's the one that we're using for design. But it really is just saying, okay, if you have all that data available in a sort of pool, you can make tools like my Unreal Engine clashing example or the section tools to review the models. You can make a tool that actually sucks that all together and you can view it all in one place. So it's not a model and not an authoring tool, but it's like the tool that can bring again together simulation, viewing, you have it, you name it. And there's like the project management and library apps. Especially today, there's very little solutions on the market, very few solutions on the market. And then finally, what I just used the generic term for sort of modern design systems, which is apps that plug into the system or current apps that modify themselves to work in this environment. So I think this is the sort of view of the world. There's tons of different areas I'm not addressing, like, design twin includes like simulation and all these things. But again, if you have up-to-date data, then real-time simulation that you don't have to watch happen, to me, falls into the category of like, oh, that's DevOps for AEC, development operations, I guess is what DevOps means. I've never said it that way, but basically you submit something and something happens automatically. To me, that's sort of if you have the right roles, then you can make the tools that do that, and people can manage that across many projects. So from a technology timeline, this is an old slide, but so you integrate this approach with existing tools. You can take that design twin concept, because that's actually quite easy. You could start working on modern design systems. You could work on drawing automation. You could work on any order you wanted. But then on top of it, you sort of have to do the work on the interchange formats, which is, again, what I'm pointing to. Sort of there's collaboration workflows, and then there's the plumbing and automation. And again, this is sort of timeline is like, it's a timeline because it goes to the right. There's nothing here that says what's being worked on by anybody, but I think it's important, again, to sort of put this out there and let the world react. And it can be open source or other. I'm not dogmatic about people having to do this open source. It just means that that the value of those things should, in this system, really come from their capabilities, not from the sort of limits they put on data access. So, and then the long term, there's just a bunch of other stuff that, again, this is the sort of catch-all. Everything I've been thinking about to build these presentations is, things we don't have that we need to come up with ideas for. It's constraints. Certainly we don't have a good concept of real assemblies, that if you're breaking the data into pieces, how you put it back together during different views. Branching is obviously something you'd get if you're going to go down the version control route. I don't know if I like this term because it confuses software developers, but the idea of an interface. So when I look at the built world, and when I was studying this in the first presentation I did, I realized that you have a certain number of objects, sort of doors and walls, and you can count those all up. But actually the technical aspects of building design and infrastructure design really are those connections between those things, and we don't actually cover that in the model world right now. We have a way of handling it, but largely we treat these as 2D bits of information, and actually, in my mind, this kind of thing should be thought as a real world object. So you could actually say that, the interface between the curtain wall and the slab edge has this requirement. We don't have that concept today. You actually put you put the requirement on the slab edge, or you put the requirement on the curtain wall, but it's actually the intersection that's the interface. And the segmented object definitions is actually what I've been talking about the whole time. It's sort of just a generic way of saying it. And again, not all of this has been updated since I worked on it the last couple of years, but I think this is getting close to the last slide. I think that's the thank you slide. Sorry there aren't any more cats in this presentation. I'm certain I will give this presentation in a cat-rich form in a public live context at some point, but I wanted to get it captured to get it on the website, just so I had it available for everybody to ingest, review, comment on. That's it. Thank you.